Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we will continue looking at decrypting other kinds of conversations, specifically two-caller communication for a SIP and srtp exchange. So let's jump right in. So in the sample calls directly, I'm going to go to SIP srtp, and I can see a normal call two-parties.pcap file in here, right? So let's actually open this up. I'm going to apply a filter for SIP or RTP. And we can see that there are SIP packets in here. We can also see we have srtp packets. So let's analyze this. I'm going to click on telephony, SIP flows. And again, if you notice, the process is identical. I click statistics, telephony, SIP flows. I'm going to select all of the flows, click flow sequence, like we've done before. Bring this down. So based on the previous video, what we know is that the SIP packet ends up carrying SDP inside of it, which contains the encryption key. So what I'm going to do is extract the encryption key for all the 4 streams. So as this is 2 callers, there are 4 streams. And let's jump right in. Let's actually widen this up a bit. Okay. So if you look at the exchange, and again, I'm going to kind of breeze through it faster because we've done all the analysis in a very thorough way in previous videos. So the first key I want is for 20.132, which should typically be in this packet, the update SDP. So let me actually, oops, my bad. Update SDP. There it is. I'm going to copy the value out. And this is 20.132. I'm going to open up gedit. And say 192.168.20.132. Here it is. And this is actually being sent to, let's pick up the direction, 20.130. So 192.168.20.130. Now the next, let's actually find the reverse one. So 192.168.20.130 sent to 20.132. This would be this packet. Here it is, copying this value out. Now let's look at the other side. So between 20.132 to 20.1, I'm going to scroll down, rather scroll up. So this SDP packet should contain it. Just hope I selected the right packet. Yep. So I'm going to copy the key out again. So this is 20.130 to 20.1. 130 to 20.1. And then last but not the least, we want 20.1 to 20.130, which should be this 200 OK SDP packet. There you go. Keep in mind this key is of course base 64 encoded. When I say the key, I'm just meaning this is really the base 64 encoded one, right? We have to decode it in order to use it. And all of that the tool actually does automatically for us, srtp decrypt. Okay, fantastic. Now we could go ahead and close this window, close Wireshark. Now we can of course verify the same thing using T-Shark by reading this file as we did in the previous video. And we can see there are 4 streams, 20.132 to 20.1. So this is 130, my bad, to 20.1. This is it. So that first stream has this key. Then we have 132 to 130, 132 to 130, which is actually using this key. And then you can similarly find the key for the remaining 2 over here. So I'm going to go inside the workspace directory, srtp decrypt, and let's actually run srtp decrypt. So -K. Let's take the very first key. This is 20, so 132 to 130. So normal call, (132 to 130). Let's actually call 20.130 to Bob. So Bob to server, right? Just easier to remember. So here we have the first one. Second one is server to Bob. So we can see that server to Bob also has data in it. And then we're going to have server to Alice. It's called 20.1 Alice. This will be Alice to server. Forgotten to capitalize A and Alice B for Bob. So you can clearly see I'm not a native English speaker, or at least I don't seem to adhere to the rules of language. Okay, copy. So this is server to Alice. Let's paste this. So normal call to parties, server to Alice. It's done. Great. So we have info here as well, server to Alice. And then finally now Alice to server. is this one here. There we go. So now we've gone ahead and extracted the decrypted SRTP sessions into the hex dump files. Next step is to use our friend PCAP to wave, text to PCAP. So I'm just going to do for one of these, doesn't make sense to do for all. You get the point. I don't want the video to be too long. So text to PCAP, the only option required is the -u option. I'm going to do a 4,000. Let's actually take normal call, let's say Alice to server, right? And after that we have out file name. So this will be normal call Alice server.pcap. Now if you were to run tshark on this, you'd actually find that we have a ton of UDP packets in here. Seems to be something else which crept in here as well. It's fine. So now we need to use the decode option. So udp.port RTP. Is that? So let's see actually if this decodes this correctly. Perfect, it does. The clear indication really is that, you know, the identifier for the stream is actually same for all the packets, right? If there was anything wrong in the decoding, this wouldn't happen. So -q-c RTP streams. Okay, fantastic. There's only one stream in there, having 1,135 packets. Now for the grand finale is to run pcap to wave.sh, feed it the pcap file, give it an output file. So normal call Alice server followed by the decode command. Just want to make sure everything is fine. There we go. So now it is extracting the stream. You can listen to this. Here it is. Or you can actually open this up in Audacity and all of that stuff as well.
This is caller 2. Welcome to Pentester Academy.
Right? Fantastic. So now similarly, you could actually use text to PCAP and actually convert the remaining 3 hex dump into PCAP files, and then use PCAP to wave to take those PCAP files and rip out the audio, right? So I'm going to leave that as an exercise to you. Doesn't make any sense for me to just repeat the same thing over and over again. So that's all I have in mind for this video. I hope you're now getting more and more confident with decrypting SIP and SRTP traffic. And if you're enjoying what you see, please recommend us to your friends and colleagues. Right? I cannot request that enough number of times, and I really would appreciate if you do that. Thank you.